This is Solving Right Triangles and day 4 of our material. So we're going to take kind of what we've been doing with our sine, cosine, and tangent, our SOHCAHTOA stuff, and we're going to talk about the inverses. So in math, it's very common. Once you learn kind of one operation, you learn the other. As soon as you learn addition, then we teach you subtraction. When you learn multiplication, we teach you division. So you kind of learn their inverses or their opposites. And so now that you've learned sine, cosine, and tangent, we have to talk about our inverses. So inverse trig functions find you angle measures. So before in a triangle, you would have the angle measure, and we'd ask you to find sides. This time you're going to get sides, and we're going to ask you to find the angle measures. And they look like this, so sine -1, cosine -1, tan -1, that's called the inverse. And you have a button for them, all the calculators do. So wherever your sine, cosine, and tangent buttons were, usually right above them, like actually on the calculator, are your inverses. So for this calculator, because they're blue, I'm going to have to hit the blue button first, the second button, and then when I hit that, I'm going to be able to use my inverse. So I'm going to show you that real quick. So if I hit the second button, and then I hit like sine, I'll get the sine inverse button so that I can use that. We're going to set up everything kind of the same. We're still going to do SOHCAHTOA. We're still going to identify our hypotenuse, our opposite and adjacent. What's a little trickier about inverses is you have to pay attention to what angle you're using. It's not so obvious on these ones. On the ones we were doing before, you had the angle measure in there, so it was easy to say, this is the one I'm using, so opposite and adjacent were kind of obvious. This one is a little trickier. So we're going to go through the 90-degree angle. We're going to identify hypotenuse. And the first one they want me to find is angle A. So from A, from this corner, the 15 is opposite and the 20 is adjacent. And I'm writing in pencil because I'm going to erase those in a little bit and they're going to actually flip-flop. But from A's perspective, that 15 is the opposite and that 20 is the adjacent. And O and A uses tangent, so we're going to do tangent. And this is just where I'm going to do the inverse, because I'm looking for the angle measure. So tangent is still opposite over adjacent, so 15 over 20. And your calculator will do that. You can just type that right in. So second and then the tangent. Then I'm going to do 15 divided by 20, just using the division sign. And I get about 36.87. We'll round to 2 decimal places. And that's an angle measure, so make sure that you put a degrees symbol on it. And we're going to do the same thing for angle C. The trick is, from angle C's perspective, that was not the opposite, that was not the adjacent. They actually flip. So for C, this would be opposite and this would be adjacent. So still using O and A means we're going to do tangent, inverse. Opposite this time is 20. Adjacent this time is 15. And so when I turn those around in my calculator, so 20 divided by 15 would get me about 53.13. So let's say I get done doing all that on my homework or on the test, and I want to know if I'm right. Remember that in a triangle, all of your angles have to add up to 180. And already you're always going to have a 90 because SOHCAHTOA only works in a 90 degree, or in a right triangle. So these two angles then have got to add up to 90 or be pretty close. So I'm going to do that angle plus this one, and I'm right on 90 degrees. Even if you round a little bit and add these two together, you're going to be right at 90. So you can kind of double check in that way. So it's not really any different. I mean, it's not a lot different from what we were doing. We're still identifying our sides. We're still picking out our trig. The difference is you really got to pay attention what angle you're going from. So from A's perspective, who is opposite, who's adjacent, because it could change depending on which corner you're looking from. These are just a quick practice in your calculator. Since we did tangent, we're going to practice both of these. Here I have the sine on this side, and I don't know how much the angle is, but they're telling me that when I do the sine of that angle, I get 0.87. So to figure out how much the angle is, I actually bring the sine over as an inverse, and we're going to type in 0.87. So it's about 60.46 degrees. Next one's cosine. Angle B equals 0.15. Again, to find B, to isolate it, I'd get rid of the cosine, and you do that by inversing it to the other side. So I've got cosine inverse 0.15. That gives me about an 81.37 degree angle. Next we're going to do what's called solving the triangle. So every side that's missing, we are going to solve for it. In any given triangle, we have to give you 3 things to start. You're always going to get the 90, that's one. And then you're going to get either two sides or a side and an angle, and you need to find the rest. So in this one we happen to get two sides. So I'm going to have to find PR, that's my last side. I'm going to have to find angle P, and I'm going to have to find angle R. So those are the three things that are missing in this triangle that I'm going to go find. So the first one, PR, is just Pythagorean's theorem. So this is my hypotenuse. So I've got 20 squared plus 12 squared equals, well, it'd be PR squared. I'll get rid of that. You could also put an X down here, or you could just have it be your H squared. That would work too. So 20 squared, sorry, you can't see it, 12 squared. And then we're going to square root that. So you could write for me both the square root of 544 and then 23.32. I'm going to do the angle for angle P, so I'm going to identify my sides. So across from P is opposite, and next to P is the adjacent, which is the 20. So O and A is what I have for information. H is of no help to me, there's no numbers there, so 12 and 20 are my match. And that's a tangent, and we're finding the angle, so we're going to do inverse, 12 over 20. About 30.96. Don't forget the degree symbol because you found an angle measure. Angle R, if you haven't quite noticed, when we're doing these, we usually end up just flipping these two. So this one will be opposite, and the 12 is adjacent to R. Still using tangent. Inverse, and we're just going to flop those guys. So tan inverse, 20 divided by 12, gives me about 59.04. And again, I can add these two to figure out if they make, or if they add up to 90. So I got my 30.96 and my 59 and right at 90. So I did it right. One more to go. So the side that I'm missing is AB. I don't know that one. I don't know angle C. And I don't know angle A. So those are the three things I need to find in this triangle. I do know right away that I can identify 11 as the hypotenuse. So when I come here to do my Pythagorean's theorem, we can just put an X there. The hypotenuse will be by itself, and the other two sides together. So 11 squared is 121. Oops, that's 25. So 121 minus 25, and then we'll square root 96. And you can write the square root of 96, or it's about 9.7. Well, 9.8 actually, once you get done rounding. Angle C. From angle C's perspective, I have adjacent and I have hypotenuse. I don't have any numbers there. I could use this one and I could do like a tangent or a sine. The problem is if you accidentally messed this one up and you got the wrong answer and then you use that answer in the next one, you're going to mess this one up too. So it's actually easier. Well, I shouldn't say easier. It's actually might cause you less problems if you use only the numbers that were in the picture. So we have adjacent and we have hypotenuse. That means we're going to be doing cosine. Inverse, because we want an angle here, we're finding angle C. And adjacent is 5 and hypotenuse is 11. So cosine inverse, 5 divided by 11, gives me about 62.96 degrees. Angle A, they're going to change just a little bit. Hypotenuse won't. Hypotenuse always stays the same. But from A's corner, from A's perspective, 5 is the opposite side. And O and H, that's a sine. So inverse 5 over 11 will give us about 27.04. And if I want to know if I'm right, I'm just going to add those two angles together, and I get 90 degrees. So this is kind of how you do inverse. This is how you solve for an angle measure if you're ever looking for one. Anytime you see the inverse of the trig functions, it means that you are solving for an angle.